Hi dear students, welcome back to the class. So far we were discussing about three-dimensional geometry, isn't it? We discussed about the equation of a line, angle between two lines, equation of a plane, etc. In this class we will discuss about equation of a plane in certain different situations. First of all, we are going to discuss about the equation of a plane which passes through a point and perpendicular to a vector. We know that we can find lots of planes, maybe infinitely many planes which is perpendicular to a given vector like this. See, whenever we are given a perpendicular vector or a perpendicular line, we can find infinitely many planes which is perpendicular to the given vector. But whenever we are given a point in addition, that is a perpendicular vector and a point on the plane, then we can say that there is only one and only one or unique plane which passes through the point P and perpendicular to the vector, isn't it? So whenever a plane, so the plane is uniquely determined or the plane is uniquely defined when the plane is perpendicular to a given vector as well as it is perpendicular, it passes through a given point, isn't it? So this is our case. So our case is nothing but the plane passes through a point P. Let it be xyz or x1, y1, z1 or anything. Let P be the point by which the plane passes through and let n be the vector which is perpendicular to the plane. So this is our condition. So we have a perpendicular vector n. So this is our perpendicular vector and let P is equal to x1, y1, z1 be the point by which the plane passes through. Okay, now let Q is equal to x, y, z be any arbitrary point on the plane. Okay, therefore we have, let the position vector of P be A. So we have the position vector of P is nothing but vector A, and let the position vector of Q is nothing but vector R. Then we can easily observe that, see, P and Q are 2 points on the plane. Also note that P is a fixed point, since that we are given with the point P and P is a particular point, namely x1, y1, z1, and Q is an arbitrary point in the entire plane, isn't it? So we have PQ will be a line or PQ will be a vector which lies on the plane. Also note that by triangular law of vector addition, we have PQ, the vector PQ is nothing but R minus A, isn't it? See, A plus PQ is equal to R. This is the triangular law of vector addition here. So we have PQ is nothing but R minus A. Therefore, PQ is equal to R minus A. Note that R is the position vector of P. Q is the, A is the position vector of the point P, where P is the given fixed point. Now, R is the position vector of Q, where Q is the arbitrary point on the plane. Note this, this is very important in identifying the formula of or the equation of the plane. Okay, let it be there. So we have PQ. Now we know that N is a vector perpendicular to the plane. Let capital A, capital B and capital C be the direction ratios of vector n. Therefore, we have vector n is nothing but A I cap plus B j cap plus C k cap. A, B, C are capital letters. So, vector n is nothing but A I cap plus B j cap plus C k cap, whereas A, B, C are the direction ratios of the perpendicular vector n. Now note that PQ is a line segment or a vector on the plane and n is a vector perpendicular to the plane, isn't it? Therefore, we have n dot PQ must be is equal to, of course, must be equal to 0, because see, PQ is a line on the plane and n is a vector perpendicular to the plane, which means that this vector and n will be perpendiculars and the dot product will be equal to 0. So we have this. That means A I cap plus B j cap plus ck cap dot, what is pq? pq is nothing but vector r minus vector a is equal to 0. Or we can say that the vector equation of the plane which passes through a perpendicular vector n, which is perpendicular to the vector n and passes through a point P whose position vector is a, is nothing but n dot r minus a is equal to 0. Very important equation. Also observe that n is the vector equation or the vector which is perpendicular to the plane. R is the position vector of the arbitrary point q equal to xyz. A is the position vector of the fixed point p is equal to x1, y1, z1. Therefore, we have the vector equation of a plane which is perpendicular to the vector n and passes through a fixed point p is nothing but n dot r minus a is equal to 0, where n is the vector which is perpendicular to the plane, a is the position vector of the given point, r is the position vector of the arbitrary point. This is the vector equation of this plane. Vector equation of what? A plane which is perpendicular to a vector and parallel to a fixed point. Now we shall derive the Cartesian equation. We know that a is nothing but x1 I cap, isn't it, plus y1 j cap plus z1 k cap, isn't it? Now r is nothing but xi cap plus yj cap plus zk cap. Why? Because r is the position vector of the point x, y, z. P is the a is the position vector of the point x1, y1, z1. Okay. Therefore, we have r minus a is equal to x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap, isn't it? So, we have r minus a is equal to this. And also note that we know that vector n is nothing but, if a, b, c are the direction, capital A, capital B, capital C are the direction ratios of the vector n, therefore vector n is nothing but a I cap plus b j cap plus c k cap. Note that these three quantities a, b, c are given to us. So because n is the vector perpendicular to the plane and it is given to us, so the direction ratios must be given to us in order to derive the Cartesian form. So a, b, c are the direction ratios of n bar and we denoted n bar is equal to a cap plus b j cap plus c k cap. Therefore, we have n dot r minus a is nothing but a dot x minus x1 plus b into y minus y1 plus z into, c into z minus z1, isn't it? Now what is the equation? Vector equation n dot r minus I must be equal to 0. Therefore the Cartesian equation must be a dot x minus x1 plus b dot y minus y1 plus c dot z minus z1 equal to 0. This will be the vector equation of the line which passes through the point x1, y1, z1 and perpendicular to the vector whose direction ratios are a, b and c. So this is the equation of the plane which is perpendicular to a given vector and passing through a given point. Very important equation. Remember this and note this down and by heart this equation now itself. Now we shall do the example number 17 of your textbook. The question is that find the vector and Cartesian equation of the plane which passes through the point 5, 2, minus 4 and perpendicular to the line with the direction ratios 2, 3, minus 1. We know that the vector equation of a plane which passes through the vector equation of a plane which passes through a point P and perpendicular to a vector n is nothing but n dot r minus a is equal to 0, isn't it? Where a is the position vector of the given point, n is the perpendicular vector, isn't it? We know that the direction ratios of n is nothing but 2, 3, minus 1. Therefore, it is easily observable that n is nothing but 2i plus 3j cap minus 1k cap. So, this is n dot. Now r minus a. We don't know what is r since it is an arbitrary vector. So r is there minus a. What is a? The position vector of the given point. That is nothing but 5i cap plus 2j cap minus 4k cap, isn't it? So this must be equal to 0, and this is the vector equation of the plane which passes through this point and perpendicular to this vector. Now we shall check what is the Cartesian equation of the plane. We know that the Cartesian equation is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, where x1, y1, z1 is the given particular point and a, b, c are the direction ratios of the perpendicular vector. Substituting all these values, we have 2 into x minus x1 is 5 plus 3 into y minus y1 is 2 plus c into z minus z1 is minus 4, so z plus 4 equal to 0. So expanding all these terms, we get 2x minus 10 plus 3y minus 6 minus z minus 4 is equal to 0. Now we shall associate all the terms containing the variables in left side and all the constants to the right side. It will become 2x plus 3y minus z is equal to minus 10 will become plus 10, minus 6 will become plus 6, minus 4 will become plus 4. So the answer is 2x plus 3y minus z equal to 20. Note that this is of the form ax plus by plus cz is equal to d. Just observe that. So whenever you see an equation of this form, observe that this is nothing but the equation of a plane. Because in most of the exams you may be given with such an expression, then you must identify that this form is nothing but the form of the equation of the plane. So this is the answer for example number 17. Now we shall discuss about the equation of a plane which passes through three non-collinear points. I hope you know what is a non-collinear points, what are non-collinear points and what are collinear points. Collinear points are those points which lies on the same line, whereas non-collinear points are those lines which does not lie on a same line, right? So here we are provided with three non-collinear points, say R, S and T, whose position vectors are A, B and C respectively. You can observe here R, S, T are the three non-collinear points since they don't lie on a single line. And A, B, C are the respective position vectors, and also note that P be an arbitrary point on the entire plane. It can be anywhere around this plane, and this is an arbitrary point with coordinates x, y, z. Those are variables. And the position vector of P be vector R. Now we are going to derive the vector equation of this plane. Now observe that R, S and T are the points on the plane, isn't it? Now we have R, S. Vector RS is nothing but, by triangular law of vector addition, you can observe a triangle here. So RS is nothing but what? B minus A, isn't it? See, A plus RS is equal to vector B by triangular law of vector addition. So RS is equal to B minus A. Now we shall calculate what is RT. See, RT is this vector, isn't it? Now A plus RT is equal to vector C. You just observe this bigger triangle. A plus RT is equal to C. Therefore RT is equal to C minus A, isn't it? So we have RT is nothing but C minus A. Now observe that RS and RT lies on the same plane. We know that the cross product of two vectors will always be perpendicular to the plane or the two vectors. So the cross product of any two vectors, we know that the cross product of any two vectors will be perpendicular to the two vectors itself. So RS cross RT will be perpendicular to RS and RT, isn't it? Now RS and RT lies in this plane. Therefore we can say that RS cross RT will be perpendicular to the given plane, isn't it? Because RS cross RT is perpendicular to both the vectors and both the vectors lies in this plane. Therefore, RS cross RT will be perpendicular to the given plane. Okay. Now we know that P is an arbitrary point in the plane and the position vector of P is given by R, isn't it? Now observe the line RP. See, observe the vector RP. RP is nothing but, R is the given point, RP is nothing but R minus A, isn't it? Why? Because vector A plus RP is equal to small r by vector triangular law of vector addition. Therefore, RP is nothing but R minus A, isn't it? Also observe that RP lies in this plane, whereas RS cross RT is perpendicular to this plane. It will occur like this. RS cross RT will be a perpendicular to this plane. It will lie on the plane like this. It will be a perpendicular to the plane, whereas RP lies in the plane. Therefore, we have RP dot RS cross RT will be is equal to 0, isn't it? Because these two are perpendicular vectors. Now you know that RP is nothing but what? R minus A dot, what is RS cross RT? RS cross RT, RS is equal to B minus A cross, this is not into, this is cross. What is RT? It is C minus A. So this is the vector equation of the plane which passes through 3 points. So this must be equal to 0, equal to 0, because these two are perpendicular vectors, these two must be equal to 0. So this is the vector equation of the plane which passes through 3 points whose position vectors are A, B and C respectively. By heart this equation, a very important equation from this session. So R minus A dot B minus A cross C minus A will be equal to 0 by this equation, which is the equation of the plane which passes through 3 points R, S and T. Now we shall derive the Cartesian equation of the plane which passes through 3 non-collinear points. The condition is, or the situation is the same, whether we are given with 3 points R, S and T. Let me name the first point R as x1, y1, z1. So the first given point is x1, y1, z1. The next given point S is equal to x2, y2, z2. And the next point T is equal to x3, y3, z3. So these are the 3 points in the given plane. This is given 3 points. Okay. And let the arbitrary point P is equal to x, y and z. Now we know that we have the vector equation as R minus A dot B minus A cross C minus A is equal to 0, which is RP dot RS cross RT is equal to 0. This was the basic format, isn't it? Now RP, what is RP? RP is equal to, we know that by in Cartesian form RP is equal to x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap, isn't it? Now what is RS? Vector RS. RS is equal to, this is RS equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now tell me what is RT? Yes, you are right. RT is equal to, what is RT? x3 minus x1 I cap plus y3 minus y1 j cap plus z3 minus z1 k cap. So we got RP, RS and RT. Now we shall easily substitute those values in this equation to get the Cartesian equation, and after substitution we get the equation as determinant x minus x1, x2 minus x1, x3 minus x1, y minus y1, y2 minus y1, y3 minus y1, z minus z1, z2 minus z1, z3 minus z1 is equal to 0. So this is the Cartesian equation of the plane which passes through 3 points x1, y1, z1 x2, y2, z2 and x3, y3, z3. Easy to remember. This will be obtained if we substitute all these values into this equation. Very simple. You can just write it out. You know how to find the cross product and how to find the dot product. So that's it. We can easily derive the Cartesian equation of the plane which passes through 3 points, and we obtain the equation like this. Easy to remember, just remember it column wise: x minus x1, then x2 minus x1, then x3 minus x1, y minus y1, then y2 minus y1, then y3 minus y1. Similarly, z minus z1, z2 minus z1, z3 minus z1. Always remember x, x2, x3, y, y2, y3, z, z2, z3. Very easy to remember. So remember these two equations very well in order to solve problems from this session. So we learned the Cartesian as well as vector equation of the line which passes through 3 non-collinear points. Now we shall do the example number 18 of your textbook. The question is that find the vector equation of the plane passing through the points r2, 5, minus 3, s, minus 2, minus 3, 5 and t, 5, 3, minus 3. It's very simple. We know that the vector equation is given by r minus a dot b minus a cross c minus a is equal to 0, isn't it? Where a is the position vector of the first given point, b is the position vector of the second given point, and c is the position vector of the third given point. We know that a is equal to, the point is 2, 5, minus 3. So a is equal to 2i cap plus 5j cap minus 3k cap. B is equal to minus 2i cap minus 3j cap plus 5k cap. And at the last, c is equal to 5i cap plus 3j cap minus 3k cap. Substituting all these values together into this equation, we get the vector equation of the line, that which is equal to r minus, what is a, 2i cap plus 5j cap minus 3k cap dot, what is b minus a, b is equal to this and a is equal to this. So we can easily find b minus a. Minus 2 is equal to minus 4i cap. Now minus 3 minus 5 is equal to minus 8j cap. Now 5 minus minus 3 equal to plus 8k cap. So this is b minus a. Cross, what is c minus a? 5 minus 2i cap. So sorry, 5 minus 2 is equal to 3i cap. So we have 3i cap. Next, 3 minus 5 equal to minus 2j cap. And that last, minus 3 minus minus 3. So minus 3 plus 3 equal to 0 k cap. So this will be the vector equation of the line which passes through the respective points. So this is the end of example number 18. Now we shall move to the next concept. Now we shall derive the equation of a plane in intercept form. By the word intercept, you know that what it means. You learned that thing in the class 11 of your textbook in the chapter 2-dimensional geometry, isn't it? The word intercept itself means the distance from the origin by which a line cut the axis, isn't it? Suppose that the plane which we are provided with cut the axis in different positions. We know suppose that we know the distance from the origin to the point of interception. Then we can easily find the equation of the plane. Suppose that our plane looks like this. Then we know that the plane cut the axis in 3 different points. Let me name the distance. This is the origin. Then suppose that the distance is a and the distance here is b and this distance here is c. More precisely, the coordinates of this point is nothing but a, 0, 0. The coordinate of this point is nothing but 0, b, 0, since this is the y-axis, and the coordinate of this point b, 0, 0, c. So this is the intercepts made by the plane in different positions. Let it be there. We know that the standard form or the standard equation of a plane is given by ax plus by plus cz equal to t, isn't it? Now we shall substitute. See, this means that x, y, z are the arbitrary points on the plane. Now since a, 0, 0, 0, b, 0 and 0, 0, c are the points on the line, each of the 3 points must satisfy this relation. We shall substitute the first point. Then the equation will become a into small a plus 0, b into y coordinate is 0 plus c into z coordinate is 0 is equal to d. Therefore, we have a is equal to d by small a, isn't it? So we get a is equal to d by small a. Similarly, we can substitute this point to get b is equal to d by small b. Now similarly, we can substitute this point in this equation to get c is equal to d by small c, isn't it? So we get a, b and c by substituting the points on the line like this. Now we shall substitute all these values of a, b and c in the original equation to get the equation of the plane. A is equal to d by a, b is equal to d by b and c is equal to d by c, isn't it? We shall substitute this in the original equation to get d by a into x plus what is b? D by b into y plus what is c? D by c into z equal to capital D. We can cancel d from all the sides, right? So we can take d common outside here and we can cancel. So the equation will become x by a plus y by b plus z by c is equal to 1. So this will be the Cartesian equation of the plane which makes intercepts a, b and c respectively. Note that whenever a plane makes the intercepts a, b, c on the respective axis, the equation of the plane will be x by a plus y by b plus z by c is equal to 1. Now we can do the example number 9 of your textbook. The example number 9 suggests us thus: find the equation of the plane with intercepts 2, 3 and 4 on x-axis, y-axis and z-axis respectively. So we have the x-intercept is named as a, it is equal to 2, y-intercept is equal to b which is equal to 3 and z-intercept is equal to c which is equal to 4, isn't it? Now we know the equation of the plane within the intercept form as x by a plus y by b plus z by c is equal to 1. Substituting these quantities we get x by 2 plus y by 3 plus z by 4 is equal to 1. Now we shall make it more into the standard form, just like by cross multiplying and taking LCM. We get 3x plus 2y divided by 6 plus z by 4 is equal to 1. So we have 12x plus 8y plus 6z is equal to 24. Now we can cancel the terms to get it to the minimum form, or this is it, we can stop by this step, or we can cancel the common terms to get into a more standard form. Whatever, the equation of the plane will still remain in the form bx plus by plus cz equal to d. This will be the equation of the plane always. So that's the end of today's session. I hope you understood the concepts we were discussing about the equation of a plane, various situations, whether we can derive the equation of a plane in a convenient manner or in the vector or in the Cartesian form, etc. So I hope you understood these concepts very well. If you have any doubt regarding this concept, just contact me and ask me. And I hope you could understood all these concepts and you could solve problems relating to these concepts. So in the next session we shall discuss more about it and we shall do exercise 11.3. So till the next video, wait for the next class. Bye bye.